First, I'm not really sure why I'm here or I'm even allowed to speak here because I'm like a JVM person, right? Kotlin is a JVM language. And now I guess the organizers of this conference already sort of hate me because no, NDC is not a .NET conference, but like for us JVM people, it sort of is, right? And there's this sort of, I was wondering about that. Why aren't we sort of ever talking about stuff together, right? It's like this completely separate worlds. We have Java Zone, oops. And I have a laptop that I've never used to present before, so it turned off. I'll just try to remember and fiddle my mouse. Oh, there we go, keep screen on. I think that worked. All right, but I'm gonna talk about Kotlin, or how not to get fired, and boring languages. So let's go. So first, a little bit about me. Let's get, nope. This is my very professional, oh, and now that's gone too. Let me try this again. Okay, there we go. How do I change slides? There we go, I can change slides. I think that's all I needed. Everything should be working now. No live coding, hopefully. So this is the way I like to sort of brag about myself. This is a screenshot of my GitHub. As you can see up in the corner there, there's like no longer maintained, a dead project. That's sort of what I have on GitHub, a bunch of dead projects. But apparently I have code on Mars. That's pretty cool, which makes me really cool and an authority on everything, about everything, especially Kotlin, right? But there's no Kotlin on Mars, by the way. So this comes from just a sort of a random thing that I did once. Because I saw a talk by like the second in command in the Linux world, Greg Hartman, and he said, just run the linter and submit a patch with just like a linter fix. So that's what I did. And now I have code on Mars. It's more like I have a diff in a repo. It's not like actually my code is running at all. It's just a compiler thing. I did the heroic task of replacing some GCC-specific macros in the FireWire driver. But it was actually kind of a bit of an adventure to sort of just what you can see here. How do you send a mail to a mailing list like this? You can't just send it with Gmail, right? Because then it will have wrong formatting. You have to have the patch file in plain text and all of that stuff. But hey, it's pretty cool. I ended up with code in the kernel. So that's sort of about me. Something else about me is that I'm not really like a Kotlin guy. Which is sort of the whole point of this talk, right? Because this is about boring languages. So I guess what I'm really saying here is that I'm not like, I don't like boring languages. I like to use fancy esoteric languages. So if I was on .NET, I would probably be using F#. I like Clojure. That's where I feel at home. And when I see other languages, I sometimes lose all hope in humanity and all my spirit and everything, but somehow Kotlin hasn't been able to do that yet. So Kotlin is like, even though I don't like those kinds of languages, I sort of actually kind of like Kotlin, which sort of makes, that's sort of the first piece of evidence that it fits kind of interestingly into this boring languages category. I'll go into some detail, of course, about why I like Kotlin later. Of course, since this is a talk about boring languages and not getting fired, we have to talk about Tayobi, or Tayob, or however you pronounce that, which is sort of the weirdest list ever, right? So, like, obviously you could use PHP, but maybe you should consider SQL or assembly instead for your next project, right? So, because I think the definition they use is like, if it's Turing complete, it's on the list. And it's just sorted by amount of queries in search engines or something like that. But this is sort of what you get thrown at you sometimes if you try to like suggest some kind of interesting language that you want to use. But well, hey, everyone is using Java or C# or C. I guess that argument sort of falls flat immediately because, okay, why shouldn't we use Python then? Why would we use Java? That's a dumb idea to use Java because Python is more popular. But I mean, there is something interesting about this, right? Because why are some languages super popular or well, I shouldn't say popular, right? Because this actually measures, you could say that at least in part, this measures the languages that people struggle the most with, right? Because they are the ones that gets the most queries. So maybe C# is more used than Java, but it's easier to use, I don't know. But it's interesting to like compare things, right? That's often what like this sort of data is useful for. So if you go longer down the list, you see Kotlin there. It's on 33rd place. So obviously Kotlin is better than both Scala and Clojure. Maybe I should have used PowerShell instead of Clojure. But these languages are so unpopular that they don't even have their logo on them in Tayobi index. But here they are, right? So they're not really that popular, like 0.40% apparently, compared to other languages are interested in Kotlin. I don't remember where F# was on this list. But again, I mean, it's a bit of a meaningless comparison, right? Because Objective-C isn't really like an alternative when I'm making like a web app backend. But there we are. But there's this weird thing about programming languages. Because I remember it wasn't that many years ago when like DevOps became a thing, and it like really exploded, right? It just took off, and now everyone is sort of using DevOps, or it's like it became really popular really fast. So why aren't everyone using Clojure then? Because according to me, at least, it's like the best language ever, and it solves so many problems. So sort of related to this, I have this list of things that, as far as I can tell, no one disagrees with this list, right? And if I were to end up in a situation where things on this list did not apply, I would sort of be willing to die on that hill, right? So if you don't use version control, I've never seen that in the wild, like for enterprise like companies. Of course, it's mostly like students and new programmers working on like their own projects. But like encrypting passwords, like obviously, time zone in timestamps, you know, this is sort of the list of like best practices. It's almost like this should be a book, almost like a software Bible, that like new programmers should just read it and accept it, like dogmatically. Don't question this, just do it. You can work to understand it. Maybe you'll understand it later, but just do this. And then, of course, DevOps. It's a little bit difficult to define DevOps in this list because it sort of depends on the context, right? If you make like a C library, you shouldn't maybe use DevOps because DevOps is more like a web thing. Even like native apps, you have to like wait a couple of days for your app to be reviewed, so you can't just like the time to recovery, right? That's a super important word in DevOps, and that's which is the time from error discovered to error fixed. And for a native app, you're sort of, well, you have to wait for Apple or Google to review your app. And of course, your users have to also update their app. So it's like a two-step thing. But this is like, I can translate this list to like hills I'm willing to die on. And DevOps is actually sort of on that list. I haven't had to like die on that hill yet. But I have like successfully introduced DevOps to someone that did not use DevOps, right? That was something I did. And then I put like a big fake stamp on this in case someone takes a picture of it and thinks this is my opinion. But I've never heard anyone really say this, and I've never had this opinion myself. Like I come to a project that uses like one of these boring languages, Java. Like, are you out of your mind? You have to rewrite everything right now to Clojure because Clojure is so superior. That sort of never happens. So what's up with that? Aren't programming languages important? Well, they are, but I guess you could also sort of make this a little bit more general. I've never really worked on a project that failed at all. I guess projects that I, as a consultant, work on don't tend to like fail. It's more like of a startup thing, but usually maybe the programming language wasn't the reason that a startup failed, right? So to sort of investigate this a little bit more, with boring languages and Kotlin and stuff like that, we're going to talk about trade-offs, which is this strange word that programmers don't like to talk about for some reason. But I'm kind of happy about this because it seems to me that we as an industry talk more and more about trade-offs. Like, I think it's not weird to say that, well, maybe we shouldn't do this just because Facebook does this, right? We are not Facebook scale. So let's just look at some trade-offs that I like. I try to sneak Datomic into every talk I do. It's like one of my favorite technologies. So here we have some databases, because when talking about trade-offs, I think the trade-offs are much clearer often in databases and things like that than in programming languages. So let's look at what Datomic does for write concurrency. So it's single-threaded. That's a pretty clear trade-off, right? So when you choose your database, this is a trade-off you should definitely be aware of. And I mean, this trade-off is so crazy that this is sort of where most people stop looking into Datomic, right? Because they see that it is single-threaded. So that probably makes it a pointless database. I can go into some detail here. I'm going to skip that. So I'm not going to bore you with Datomic stuff now. I like to talk about Datomic. But DynamoDB, right, because this is trade-offs, it's like completely on the other end of the scale, right? I think Snapchat uses Dynamo, right? And during Super Bowl or something, and they had like 5 million writes a second to their like one table. And actually latency was lower, right? Because Dynamo loves scale so much that everything was cached and ready and was super fast. Was it yeah, like during Black Friday, or what Amazon calls it, Prime Day or something? I think they had up to like peak 70 million writes in like a single second. So that's quite a different trade-off. Obviously, that won't work if you're single-threaded. SQL, I'm going to get into that later. The read model of Datomic is sort of opposite. So it's like 100% consistent because it's like the writes are single-threaded, right? So you can actually talk about a point in time, right? Because there's no concurrent writes. So you can like go into a point in time and do your queries on that point in time. And queries run on your app server, which is kind of crazy. Another one of those things that make people go, what? You're supposed to not run queries on your client, right? You're supposed to not fetch all your data and then filter it. You're supposed to use SQL. So that's a clear trade-off. And DynamoDB is, of course, on the complete other end of that scale. It's eventually consistent, and it basically doesn't have queries because it's a key-value database, right? So it's just like simple lookups. SQL, you know, that's one of the problems. Sort of depends, right? Depends on your settings, and does someone write at the same time? So it's much more complex. Data model, 100% normalized in Datomic, and DynamoDB is exactly the opposite, 100% denormalized, because you basically have to write your data as you will access it. You have to know your access patterns beforehand so that you can just slurp the data in. That's what makes DynamoDB able to be web scale, right? Because obviously you can't do SQL and then have super fast queries and super fast writes at the same time at that scale. And then, of course, SQL data model is sort of mostly normalized, I guess. And sort of my point here is what we can see here is that we have this very clear choices, right? These clear technical choices. So Datomic, this is exactly what I am. I'm single-threaded. DynamoDB is exactly the opposite. Like if you have to go web scale, we'll solve that problem for you. SQL, like technically, it's a little bit fuzzy, right? Exactly what it does. So there's another kind of trade-off that we have to discuss. And that's what I like to call the meat in chair trade-off, right? Because that's also part of software development. There's a bag of meat in a chair. So has to write this code. And like all of these really cool databases that I've been talking about has this problem of there aren't really that many people that know it, right? It's not mainstream. I guess you could say like that Dynamo is mainstream because it has like a lot of users, at least compared to Datomic, which is this almost like esoteric thing that only Clojure people use. But is Dynamo mainstream in the same way SQL is mainstream? I wouldn't say it is. And we also have these other databases that I really like VaultDB and CockroachDB. They all have this problem, right? There aren't that many people that know how to use them, and you would have to train them. MongoDB, I put in this sort of limbo. I guess it's not that commonly used compared to like SQL. But it's like relatively easy to get started with Mongo, right? So they've chosen sort of the API and the whole way the database works. Okay, so you might need training, but it's not that difficult to like get into MongoDB, which is sort of what made MongoDB popular in the first place, right? This new different database, and it was so easy to get started, and it was so easy to lose 60% of your data in high-scale settings and stuff like that. There's been some horrible accidents with MongoDB. By the way, I can recommend, there's this Kyle Kingsbury. He has this thing called Jepson, where he just dissects databases. So he has this test rig where he makes them do crazy things and times out, and basically all databases, I think even Postgres, which is like the stable one, right? He made that, even that able to fail in a situation where it's always like when there's multiple servers and stuff like that, right? One server usually works, which is also the case for Mongo. So anyway, I was sort of dissing SQL a little bit here, right? This is technically not that interesting, right? I can do everything, not that good, maybe badly. It's sort of up to you to tune it. Doesn't have like a clear stance, but SQL has this, or SQL thingies like SQL databases has this huge advantage, right, of being able to find people who knows the thing. So I think this is sort of, this is where boring languages sort of enter the scene, right? And this is the trade-off that you have to keep in mind when you choose your language. So if you're making like a small, very technical startup thingy where tech actually matters like a lot, maybe it's a good idea to choose like this weird esoteric programming language that can help you. But if your situation is that you will maybe in a year need 50 programmers, you have problems, right? So maybe it is better to use the SQL thingy. And it also depends, right, on your needs. There aren't that many startups with like crazy technical requirements, right? It's usually just some CRUD and some validations and a database and some queries and an app or something like that. So, Kotlin. Let's talk about Kotlin. I made the same table for programming languages. Of course, we know Java and C#, right? They're the workhorses. It's easy to find people. And Scala and Clojure, my favorite language, Clojure. To be honest, I probably know everyone in Oslo doing Clojure, right? It's like not that big of a community. Or if you create a startup in Oslo and you use Clojure and you suddenly need to hire 50 people, well, there aren't 50 people probably, right? So you have to start training them, and I mean, maybe you want that, but at least it's a trade-off to be aware of, right? And this is sort of where Kotlin fits in, I think. So I've labeled it the same as MongoDB here, which is a little bit unfair because the comparison is only like in the meat in share trade-offs. Because you could argue, right, that Mongo is like it's a little bit sloppy, right? As I mentioned, people have lost data in production and stuff like that. But Kotlin is not like that at all. It's just the meat in share thing we're talking about here. So Kotlin is similar enough to the existing languages that I believe that you won't really have the finding people problem because it's not like completely different from the other languages that most people already know. Also, I know this from experience, actually. I've onboarded a lot of people in projects that didn't know Kotlin already, and it worked out well. So let's talk a little bit about Kotlin specifically, right? So I would argue that Kotlin fits in this boring language sort of world, right? Where you need just a language that can get the work done. So now I'm going to basically talk about why you shouldn't use Java but use Kotlin instead. And of course, null is a big problem for us programmers. I'm going to mention a little bit in detail later about how Java handles null in various weird ways. Of course, I guess everyone has heard this quote by now. It's a famous quote by the guy who basically invented null, right? And it sort of came from implementation details. It was easy to make it. It was sort of useful, I guess. And he now calls it his billion-dollar mistake, right? Because it has sort of ended up in a lot of programming languages, causing lots of problems. And I think actually when he said it was my billion-dollar mistake, that wasn't just sort of something he said. I think someone made some calculations, right? How many problems has null pointer errors in Java actually caused, or other languages? And the numbers were on the billion-dollar scale. So let's look at Java. So since this is like not a .NET conference, but a little bit a .NET conference, I sort of feel safe in like dissing Java. No one here likes Java, probably, right? I don't like it, but it's one of those mainstream languages, right? So Java made this attempt at making nulls sort of easier to live with by adding this optional type. So I'm going to assume everyone here knows generics and stuff like that, right? So like an optional of string, that's like the type system telling us that this is maybe a string, right? It's a string or it's null. But it doesn't really go that far, right? Because this code will cause a null pointer exception, because I can return null from this thing. I'm supposed, right, to return like an optional empty, which is like the null version of optional, or yeah, the optional version of null. But I can still do this, right? So Java doesn't really help me that much. And to be fair, right now I'm sort of there are a number of highly competent people who makes Java, right? And the goal with optional wasn't really to help us programmers handling all issues around things being null. It's like the stated goal was basically like API design and libraries, right? So that if you made an open source or a library of any kind, or any API that other people would call, you like had something to let people know that, okay, this isn't actually always a string. It might be optional. But it doesn't solve the null pointer thing, right? Because this code obviously, because get thing returns null, it doesn't return an optional. So let's look at some Kotlin. So Kotlin has actually like first-class handling of nulls, which is like really nice. So what we've done here is that we created a value which is like an int question mark, and that's Kotlin's way of saying that this could be null. And look at how dumb computers are, right? We know this is obviously not null. It's 5, can't you see? But the type system trusts us. So this gives us an error. We can't add 2 to A because it could be null. And it's like a first-class feature in Kotlin, right? So this is, I think, the proper name for this. And like, remember now that I'm a Clojure guy, right? So anything I say about proper names for things in type systems might be not true. But I think this is a union type, right? It's like a proper union type. This is an int or null, and the type system knows about that and can act accordingly. Now, as someone who really likes Clojure, another way of saying that is that I'm someone who really hates satisfying type systems, right? That's not what I want to do. And I landed on this being subjective, right? Some people just like different things. People have tried to argue what's better or worse, like objectively speaking. Don't think anyone has succeeded yet. But like personally, I don't like to have to satisfy a type system. So I was doing some iOS stuff and used Swift. And this just kills my spirit immediately when something like this happens, right? And because you see, Swift has exactly what Kotlin has. So you can say that something is an int question mark. And it's, I believe, like as good as in Kotlin, it's like union types. The type system knows it's an int or null. But if I do this, I get a type error. So I check that if A isn't null, do something with A. Oh, sorry, it's definitely not something you can do because it could be nil. Like one line up, guys. I'm saying it's not nil, but Swift doesn't care. Kotlin, on the other hand, does, which is like one of the things. So this sort of experience made like Clojure me using Kotlin for the first time. Just, yes, I do not have to please the type system with this sort of thing. And it's really nice to have these like sort of optional types built into the language because null is a problem, right? This is just lovely. I think Kotlin calls this smart casting. So inside this if block, A has actually, the type of A is int, right? Not int question mark. So that's good. I want to show you something in Typescript, which is kind of interesting. So Typescript has the same thing. And I guess this sort of, I like Typescript, right? And this says everything you have to know about me as like a type system person, because I think people who like really like type systems think of Typescript and Kotlin as sort of like the sloppiest, worst type systems, right? But this sort of thing really sort of is something I like, right? And it's basically the same thing, right? In TypeScript. So you say that foo can be a number or null, but if you check if it's if it's JavaScript, right? So null is false because reasons. And I can do this, and TypeScript will do like the same type of smart casting that Kotlin does. However, Kotlin is in a little bit different universe than TypeScript, because TypeScript compiles to JavaScript, and Kotlin compiles to, well, Kotlin actually compiles to many things. You can compile to native code and JavaScript. But this is like JVM Kotlin. And we'll get a type error here by doing like exactly the same thing. And you would think that I would sort of really hate this, as I've described myself so far, right? Ah, damn it, the type system is in my way. But is it really? Like, this is the sort of thing that I actually sort of like that the type systems help me with, right? Because the problem here, compared to TypeScript and the JVM, or like anything that isn't JavaScript, is that there's a thing called threads, right? So the type system does not know that after the if statement runs, it could be, right, that some other thread got in there and changed it to null. So the type system can't guarantee that this isn't null. So this is sort of what I feel like this is a great help to get from the type system. It doesn't feel like it's in the way at all. Of course, the solution is to sort of fetch it first, right? And then you have your own thread-safe reference to it. And then you can check if it's not null. And now comes my favorite part of the Kotlin type system. So I guess it's really nice, right, to have all this help if something is null, if something is not null. And Kotlin really helps me, right? I can't accidentally call a method on null like I could in Java, right? I said it returned an option string, but it also could be a null. Java has no idea, but Kotlin does. But then there's this thing called the real world, where things might not act the way you think it is, and things might not be instantiated the way you think it is. This is like the biggest type system hack I'm aware of, and I absolutely love it. It's what Kotlin calls late init. So I guess I'll just show you some examples to get us started. So this is, I'm showing you lots of weird JVM stuff today. Has anyone here programmed in Groovy? Groovy? No? No Groovy programmers? Oh, there's one hand. There's some Groovy. So this is when I worked at NSB. This is a thing called Spring Context. So I kind of like this actually. We ended up not using a framework, but using like things that we liked. And even like in Clojure land, like obviously I'm a Clojure guy, right? So I don't like Spring and stuff like that. But instead what we do in Clojure is that we make our own versions of what Spring does and then just call it something else, and then it feels like I'm not doing enterprise stuff, right? Because this is actually like a useful thing to do, right? Because what Spring Context does is that, so here are sort of my thingies that I need to have my system up and running. But the problem is that I can't just create them. They have to maybe be created in a certain order, right? Because this thing has to be connected before it could talk to this one. And it's sort of nice to have this whole thing do that for us. And especially in things like tests, if you're doing like heavy integration tests and spin up your whole actual application, it's nice to have like the other way, right? Automatically, the teardown. Because if you do that, you could of course just do this by hand, right, in a function. But it's nice to have this sort of helper code that gets you up and running. Of course, the problem with this is that your Kotlin code ends up looking like this. So this is the class that gets instantiated, not by you, right, but by the framework. And then, of course, it gets instantiated without any properties set, right? Because the way it happens is that it creates a bunch of objects, and then when everything is up and running, it sort of sets all the properties and connects everything together. And then you sort of lose all hope of having like a good setup around nulls, because then suddenly everything can be null. And then you have to check everything that it is null. But you know, right? You know that it's never actually null, right? None of my code will run while it is null. And this is what late init is for. Oh, I just love this so much, right? So this lets us tell the type system that, okay, this is never null. Actually, it's null sometimes, but you don't have to worry about that. I'll take care of that. That's what late init is, right? It's just, oh, it's glorious. I love this so much. Because I can sort of rely on the runtime guarantees of this whole Spring Context thing, that it won't actually make any of my stuff run before it's connected properly, right? So it will, like, technically, it will be null sometimes, but like actually, it won't be. And here is like a little bit of a more concrete example with Android. So Kotlin is sort of a little bit moot to argue that Kotlin can be mainstream because Google uses it for Android, right? That's pretty mainstream. It was Java, or it is still Java, and now they sort of Kotlin is the sort of the main language for Android. And we have the same problem here, right? So we have this initialize function that is called by someone somewhere, and it sets this DB thing for us. So obviously, when this class is created, the DB is null, right? Because you have to call initialize first. And like, for reasons I won't get into now, I can't just do this in like a constructor because I have to rely on the Android system, which is something like this, right? So I have this application, it starts up, I don't sort of create my own instance of it, so my whole sort of environment is like, oh, here you are, you're up and running, and now run your code. So I call like initialize, the last method there, and set the thing on the thing. So like I know, right, it's actually never null. This thing will never be null. I mean, technically, it will be null at like inception, no, at like birth, but it's not actually null on the runtime. So then I get like all the really nice null help from Kotlin, right? I can't just accidentally call a method on something that could be null, but this can actually not be null. So I get that help late in it. I really like that. But I guess maybe it's, I mean, at least Clojure programmers like it, right? Because this is the sort of thing that sort of drives me mad, right, by satisfying the type system. So I can sort of loosen up the restrictions a little bit with this late init thing. However, it's time for the glorious type system buy-in, because you can go pretty crazy with Kotlin. It's a very flexible language. It has this... my brain is stopping. I'm going to give myself 2 more seconds. Continuations. Yes, thank you for waiting. So the continuation API and some other APIs in Kotlin allows you to basically like customize things in a type system in a pretty sort of extreme way. An arrow is basically like how to make Kotlin more like Haskell or something like that. So this is like Kotlin is mainstream, sort of when you use it, basically, like in its sort of core version. But as soon as you sort of apply arrow or something like that to Kotlin, it's very much definitely no longer mainstream. So I'm going to show you like one specific example, and this is sort of my main rant of the evening. It doesn't, I mean, this sort of only vaguely applies to Kotlin, right? Because this is a problem you get as soon as you use something like arrow. Or this problem is even true for like the option type in Java as well, right? Because the option type in Java is the same as the maybe. It's like 2 different names for the same thing. Right, so the whole idea between this type is that you want to be able to say to the type system that you have like, this is not always a string. It could be a string, but sometimes it's a none, right? So it's the sum and the none. So a maybe is, it is one of those sort of union types, right? It's either a sum or a none. And if it's a sum, you can get the value from it. And if it's a none, well, you can handle it as if it was a null, right? But you don't have a value. And this else, this will never happen, right? Until you see it in your production logs, of course, because some weird thing happened. But it should never happen. And that's sort of the whole idea behind maybe. And I guess like in other type systems that doesn't have this int question mark thing that Kotlin has, like Java, for example, this is sort of useful as its own thing. And of course, this whole maybe idea, I think maybe is a monad, but I'm not sure. I don't understand monads, but I think maybe it's a monad. So if you like go all in like functional style, which you can do, like right with arrow, then maybe it's well, I'm not going to refine it too hard, right? Because if you go that route, maybe it's this really nice construct that lets you chain stuff and have it gracefully stop if it encounters a none, and it's like it's in many ways it's a good thing. But like my this is my very sort of subjective gripe with this thing, and makes it obvious that I'm a Clojure programmer at heart. It feels a lot to me like having to satisfy the type system, and it sort of infects your domain in this weird way. Like, because I like to say that, okay, I have an address, that's good, or I don't have an address, but I have a maybe address. Again, this is very subjective, right? But the Clojure guy in me is sort of a little bit triggered with this whole maybe thing, because I have to satisfy the type system in this weird way. But there's this other thing with maybe that, well, this is actually two parts. So I'm going to start with the objective part. It's just a completely sort of objective observation when you use maybe. So the objective part is that if you have, so you have this function, right? And it returns maybe foo. That's how you set it up. So that's good. And then you assemble a team of your best programmers for many weeks, and they enhance this function, and it becomes so great that actually now it always returns foo. It doesn't return maybe foo anymore. So that's good. And then you make that change from not returning maybe foo, but it always returns foo. So you made it better, right? Or stricter, or what do you want to call it, and then you break your callers, right? Because those two types aren't compatible. Maybe foo and foo aren't compatible. All the code that checks like, is it a sum or is it a none, that will break. Then you have to refactor your code. Of course, it's the same the other way around, right? If you have a function that takes a foo, and then you change it. Oh, I don't actually always need a foo. You can just give me a maybe foo. That will also break callers, right? I mean, you could always refactor, but this is sort of the objective part. I mean, that's just an objective statement about maybe. My subjective opinion is this is like a bigger problem than we sort of think, right? Because it's one of these sort of invisible things that sort of crops up in your code, and then, oh, we deal with it, and of course your compiler helps you, right? Of course you will see all the places in your code that you broke by making it sort of less strict. But yeah, this now we've also like immediately entered territory where Clojure programmer me just gets so annoyed, right? I made it like better, but I broke everything. Super annoying. But of course, this is not really Kotlin, right? Kotlin doesn't have a maybe type built in. This is if you have to like pull in this arrow thing to get maybe. So let's look at what Kotlin has to give us. So here we have a function. It's a pretty simple function. Adds 2 to a number, and of course, this is how you do that in Kotlin. You return and check if the number is null. You just return 2 because this treats null as if it is the number 0, right? And if it's not null, we add 2 to it. And of course, you can see here what I've talked about before, right? The smart casting and all of that. You don't have to cast it to int without question mark inside the if statement. Kotlin already knows that it's an int, not an int question mark inside the if statement. And then I have like my a at the bottom here, which is it could be an int. Maybe not, it could be null, so it's 5 now, but we tell our type system that, well, it could be null, right? And of course this works. Now we're going to play that per game, so can you like spot the difference? Can you see the difference? Does anyone see the difference? It's in the bottom there, right? And these are both programs that compile, right? Because Kotlin knows this, right? Because the int without a question mark, of course, it's okay to pass to a function that takes maybe an int, because an int is maybe an int, but since it's not wrapped in this whole maybe thing, it sort of just works. So again, when I see stuff like this, it makes the Clojure programming in me happy, right? Because I don't have to do all this work to refactor to satisfy the type system. Because it's like a first-class thing, and it's like maybe it's a little bit of a mind trick, right? Just because it has the name maybe, it doesn't like act like a maybe. The programming language doesn't have a deep knowledge of what a maybe is, but the option types with the question mark in Kotlin actually knows about them, right? So we can do this sort of thing, and you can actually make like this program better. Yeah, it's always a number, and the function that takes, well, it could be a number. Of course, it accepts always a number, right? It's just the way it should be. And just to sort of wrap up my little arrow rant, this is a little bit unfair. So the point here is to sort of look at all this code, right? So much stuff you have to do to satisfy the type system. It's also like a big system that's evolved over time. But I just, when I was preparing this talk, I sort of found some old arrow code that we used. And there's a lot of stuff here, right? That I don't remember now, like SR, what is that? Is required, yeah, I guess that makes sense. It marks it required named. I sort of know, right? I have the cheat because I've been part of writing this code. This is like mostly satisfying the type system type things, and I'm a little bit on the fence. It was sort of nice to have all this monady stuff and type system things, but I mean, this is like now it's very far from mainstream, right? That's basically my point. This is not what I would call like mainstream code, because this is Kotlin with arrow. So I will be careful with that. I'm going to wrap up now. This is a thing I like to say. Java is that language that comes bundled with the JVM. Like, why would you use it? Right? You buy Java to me is like when you buy like a router or something, and it comes with a CD. Has anyone ever used that CD? Why is this CD here? Do you need like a CD to make your router work? No, you just plug in the router and it works. So this is sort of my view on Java. I mean, it's a good reference implementation, and but now that we have Kotlin, I would sort of not like to be on a Java project, knowing that it could have been Kotlin. And I actually have the same sort of view when it comes to JavaScript. And this seems to be like can you see the little Typescript logo that's hiding down in the corner there? I also sort of prefer to use Typescript instead of JavaScript. So I guess Java and JavaScript has this in common. It's this weird language that comes bundled with the thing, but maybe that's not the language that you should be using. So in summary, even I, a Clojure fan, is able to sort of tolerate Kotlin. And not just tolerate, I sort of kind of like it actually. And as I said, like Android is pretty mainstream already, right? So Kotlin is sort of half mainstream, or it is 100% mainstream when you make an Android app, right? So it's a relatively safe bet. Kotlin is, as I said, meet-in-chair friendly. As long as you don't add arrow, of course, then it's no longer meet-in-chair friendly, it's meet-in-chair hostile. The part where Kotlin just solves null, lovely. Don't ask me what that little asterisk is behind solving null. Because of course, right, the real world comes and bites you sometimes. You can do things in Kotlin that gives you null pointer exceptions. And then, of course, my little rant about the maybe type. I have a problem with that. And just to be sure, if you get fired for using Kotlin, I am not liable at all.